So is carbon fiber PLA actually stronger than regular PLA? Well, in this video, we're going to use a very expensive piece of machinery in order to find out. Now, first, some details about this test. This is a traditional tensile test. We're using dog bone samples that are 4 millimeters by 13 millimeters. We will be presenting main data in force in newtons so that you can then reverse engineer stress, but newtons actually implies how strong an item actually is within the context of the actual intuitive shape of these parts. We will try to include stress as much as possible, but stress is an engineering version that can be extrapolated from these and isn't really useful for a video, so we're going to go into that a little bit more. But let's go ahead and get right into the tests. So right off the bat, we ran into a number of issues when testing these samples. Because carbon fiber is an additive to PLA, we kind of expect it to be more brittle because now you have less material actually holding stuff together. A pure PLA sample has resin on resin, but with carbon fiber filled items, or really any sort of filled material, you have the fill, and the fill doesn't really stick to itself. It needs the resin to act as a binder. So if you have less binder by putting in the filler, you would expect it to be weaker. But carbon fiber is often considered to be stronger because it's carbon fiber. Carbon fiber is great. But the key notification here is that the carbon fiber used in most carbon fiber PLAs, especially lower cost ones, are not fibers. It's just chopped carbon fiber. So it might as well be chopped glass or chopped sand or really chopped anything up at all. Because carbon fiber sounds cool, but I wouldn't really expect it to improve the strength of the part. But let's go ahead and find out. But one of the issues that this created for us was actually the parts were quite brittle. When setting up these tests, we set them up to have 10 tests of each one of them. We then ended up having failures of the parts in process. So we actually lost a couple of tests, and the schedule of the video has to go on, so we had to run with the number of tests that we had. We did attempt reprinting, but when you're printing up a batch of 10 of these vertically and you have a material that is somewhat persnickety, again, timeline doesn't allow us to fight that particular battle. But let's go ahead and get into these tests for real now. We know that standard PLA, standard black PLA run out of our extrusion with no sort of fillers at all except for the colorant, is able to take a maximum force of about 1700 newtons and all the way down to about 1300 newtons depending on the situation, which is a tensile stress of about 33 megapascals. The very first item we tested was Polymaker CF. And this one, when we tested through it, the average force that it was able to take was 717 newtons, which is a full 1,000 newtons less than standard PLA. Now that's not a great result. After popping a whole mess of these, it ends up being 1,000 newtons less, almost 60% less than just regular old PLA. That's not a great outcome. Now, this is true for most filled things, like we kind of discussed. This is within what we would expect from having stuff thrown into the toothpaste. But the benefits of carbon fiber that you can see is both improved surface finish as well as potential abrasive resistance. Because the carbon fiber filler actually acts like a rock inside of there, so if you wanted to sand it down or something like that, it would be more resistant to that type of wear and tear than regular PLA. But it does appear to become much more brittle, where it just breaks more easily at a lower value. It's very fragile even. Now again, there's also like the geometry components of this, where you could design for the carbon fiber material in order to make it tougher, but that's not really material strength. That's actual mechanical design. So let's go ahead and move into the next test, and hopefully somebody can improve it a little bit. The next test is of the cheapest PLA we could possibly find, which was called Force Tracer, and it is a carbon fiber filled PLA. In this case, cheaper is not better. We ended up with a maximum of 550 and a minimum of 420. This is not good performance. This is almost a quarter, getting very close to a quarter of the actual strength of standard PLA. So carbon fiber really does not appear to be helping this at all. But the third test might be able to actually kind of adjust this just a hair. The third and final test that we did was actually Creality carbon fiber filled PLA. And this one actually did redeem itself a little bit, hitting the sweet spot force of about 1,000 newtons, which was more than Polymaker and certainly more than Force Tracer. So it was stronger. And it was able to be at least more than 50% strength of standard PLA. So overall, PLA carbon fiber doesn't really seem like a good idea from a strength standpoint. But there are a few factors that can affect this. We did not talk about the actual carbon fiber density inside of these materials. But the reason for that is the only one we actually know is the force tracer stuff. The cheapest carbon fiber PLA had a 5% carbon fiber density, which is really not very good because you would think that since it has such a low density, you would be able to actually have it closer to actual PLA, but that wasn't the case. The other ones, the Polylight CF from Polymaker and the Creality CF, neither one of those would give the number of actual density of carbon fiber in the material. If I was making a hypothesis, I would say that Creality had the lowest density, but when you actually see it in real life, it doesn't really look like it, and it's still quite brittle. And we also don't know what the base PLA resin is. Did they put in additives of some sort or anything else? No idea. There's not technical data sheets or anything else on these materials, which means the only information we have is the test data that we just did, where we can now extrapolate the actual material properties of these. Properties appear to be about 10 megapascals for the force tracer, about 20 megapascals for Creality, and about 15 megapascals for the Polymaker. None of these are very good when we had strength of about 30 pascals for traditional standard PLA, regular NGO 4043, of which there are data standards and of which we do know what was put into them because we extruded the filament ourselves. It's Tangled PLA, which can be purchased over at tangledfilament.com. But this is just a really good indication of the necessity for this type of testing. When we're going through these tests, we're continuing to refine the process as best as we can while still producing these videos that are useful to you guys. But this is why manufacturers need to be held accountable. Carbon fiber sounds really good, and it has lots of benefits. It has better surface finish, it can have better abrasive resistance, and it can have some good impact properties when you design the part right, because you're creating something that is potentially more durable. But opt carbon fiber is much more of a buzzword than anything else. It does not improve the overall strength of the part, as many people think that it does. It is kind of gimmicky, and it can actually hurt the part itself by just breaking up the actual interlayer adhesion of the pieces. So we'll continue testing these and adding new variations of the tests over time. This is a test where it would be good to do a horizontal test, so make sure to subscribe and comment if you would like to see these samples printed horizontally to see if carbon fiber actually makes a difference in that direction, or if having sand inside of your glue actually makes the glue stronger or not. So subscribe and let us know anything you think about what we're doing down below. We will have more of these tests coming out around very common Amazon filaments as much as we possibly can while still maintaining the schedule so that we can start getting good data out around how these different materials behave. Have a great day, everybody.